Hey guys, welcome back to another video in this channel. Today we're going to continue with more 3D basics, or what I would like to call 3D basics, which are just general information about the 3D world. I think this is a nice series. Let me know in the comments if this is something that we should keep going or keep moving forward. Of course, we're not going to have this every single week or every single I don't know, month or something, but maybe have it like a specific series where you can check out specific topics. I think that would be quite nice. And today I'm actually going to be jumping out of my comfort zone, and I'm going to be showing you something interesting here. And the reason I'm jumping into Blender is because last Friday on December the 3rd, Blender 3.0 was released. And I'm going to be completely honest with you guys. About 3 or 4 months ago, we released here in the channel a video comparing Maya and Blender. And I did mention that I was biased towards Maya because I've been working on Maya for 10 years. But after looking at all of the comments and all of the discussions over there, which pretty much all of them were nice and civilized, I realized that, hey, there's no harm in trying to learn Blender as well, right? So I've been learning Blender. I've been exploring Blender throughout this last couple of months. And let me tell you, I'm impressed. It's a really nice software. There's a lot of things I really like about it, and there's a lot of things I don't like about it. My best advice as a Maya user for so long is, if you're already strong in a software like Maya or 3D Studio Max, Cinema 4D or whatever, pick Blender as like your side weapon. You know, if you're playing shooters, you always have like your main weapon and like your side weapon, because there will be things that Blender will be able to do maybe more easily than what you would find inside of Maya, and the other way around, right? So there's no harm, and the fact that Blender is free, well, that there's no excuse to do it. So if you want to learn Blender, go check our channel, because there's 2 videos by Alejandro, one where he goes over the basic interface of Blender and all the basic stuff, and another one where he builds a very cool sci-fi wall. So if you want to start learning a little bit about Blender, then check those out. Today we're going to be talking about displacement maps, and the reason I want to do it inside of Blender is because in the newest Blender they released something called Cycles X, which is like the new evolution of their render, and it's really fast. So it's going to allow me to show you some really cool stuff. So what is displacement? Well, displacement is a technique that we can use inside of the 3D packages. Again, not only Blender, every single software, most softwares have displacement information or displacement capabilities. And what it does is, at render time, or at any moment if you're doing like real-time render, you will subdivide the geometry of an object multiple times, and then you will push the vertices up and down. Yesterday we were looking at normal maps, and even though normal maps are really good, one of the problems with normal maps, as you can see right here, is that they will not change the silhouette of the object. It won't modify it. It's just a fake detail. So whenever you're seeing straight at the object, like the camera, that's gonna look good. However, if you go to the silhouette of the object, it's gonna look a little bit wonky. So normal maps are really good for like flat surfaces like planes or walls or ceilings. Like all of those stuff is really good. But when you really want to have like that geometry moving things around, then that's where displacement comes around. And displacement has been around for a long time. In games, we don't call it displacement, we call it tessellation. That's like the name that they use, even though it's pretty much the same thing. So tessellation, what it does is, again, in real time or at render time, they will triangulate at the objects, add more divisions to the objects, and then they will push the vertices up and down. Like the new triangles that get created get pushed up and down, and we'll get a very nice detail. Unfortunately, as you might imagine, these techniques are quite expensive processing wise, so you won't be able to have a game with everything with displacement or tessellation. However, it is a good thing. Nowadays, or at least the new future, is Nanite. So Nanite for Unreal, it's amazing. We're going to be taking a look at this once we hit that part on the Lighthouse tutorial, which we're continuing, don't worry. But the Nanite technology, it's kind of like decimation in real time. So you're going to be able to import objects, and I've done this. I've tried. I have the Unreal Engine 5 build, like the beta release that they have, and you're going to be able to see amazing detail in real time, like with no hit to your performance, because it uses, well, algorithms and, you know, programming things that make it so that it's easy to process. So eventually we're going to be on a point where we won't have any limits as artists, and we're going to be able to pretty much have everything on screen. The only thing, and I've mentioned this before, the only thing that Nanite does not do is deformation. So you can't do a skinned rig character, like animated character, using Nanite, as long as it's skinned. You can, however, if you constrain things and do like a robot that, or like they have like a giant golem, you can use it. But enough of this talk. Let's talk about now the subdivision again. And one of the most important things that we're going to be using is the Catmode Clark approach. So a couple of you guys were a little bit curious about this one, so I made a little bit of research. I only knew that the Catmode Clark subdivision was done by at Catmode. But I didn't know it was this this long ago. Look at this, 1978. That's a long time ago. I thought he did it when he was in Pixar, but no, it apparently was done when he was in school or something. So this Catmode Clark subdivision surface is an algorithm. It's a sort of sequence that they created, which is all of this explanation right here. If you guys are into math, we'll take a look. But what it basically does, or at least as I understand it, if you have 3 points, right, like on a face, let's say this is like a cube, it will calculate the middle of those points, and then it will calculate the middle of those new points, and then it will calculate like an average of that extra point right there, and it will create new topology to follow that curve over there, like this. That's why we have our support edges. When we do modeling, that's why we add support edges, because it helps the algorithm find where we want to keep more geometry and less geometry. Here's the full explanation. As you can see, it's a little bit complex, or at least for me. I'm not super like tech savvy in regards to like math and stuff. But if you want to check like the formula they use, well, there it is. And the cool thing is you're gonna find this everywhere. So for instance, here inside of Blender, if I grab this cube and I go into my modifiers and I add the subdivision surface modifier, you're gonna see that we're using the Catmode Clark variation, and that's what it's doing. It's just subdividing this thing so that it looks kind of like a sphere. If we increase the levels, of course, we're gonna get more divisions, and every time you up a division, the same like algorithm applies with the new faces that you have. So very, very, very cool technology. Now, displacement is one of those things that can be a little bit confusing at first, but I'm gonna try to explain it as nice as possible. So first I'm gonna press Shift A and I'm gonna create a plane. There we go. And let's scale this plane a little bit more. There we go. Let me go into my camera. There's one thing I personally like about Blender is go into view and change this to camera to view, and now the camera will behave a little bit more like when you jump in Maya and do like look through camera. It's just I feel a little bit more comfortable doing it this way, but there we go. So just focus this thing right there, and you can press N is the shortcut to open this like view menu, and then let's just go out of this. So we're gonna jump to our trusty page, Pauly Haven. For those of you that are not aware, Pauly Haven, one of the best pages, Pauly Haven out there for 3D content. They have free HDRs, free textures, and free models. By the way, I don't think I've mentioned this, but they do, since it's a free page, they work based on donations. So if you want to donate at any point, feel free to just click over here and you can donate as much or as a little as you want. Everything is good. And as you can see, 100% free, CC 0, so completely free, and you don't have to credit. You can use it without restrictions. So yeah, so I'm going to go into the textures here, and let's look for a texture that looks good. Something that looks interesting and hopefully has a lot of like visual interest. So like this one right here, rocks ground. So maybe you're doing a render and you are modeling, let's say we model like the beach house, right? Like maybe we want to use this on our beach, or the beach lighthouse, on the lighthouse, and we want to have like this ground. And as you can see, this is actual displacements. I know this is displaced because I'm seeing the shadows. Like it's not a flat surface. There's things like pushing in and out of the surface, and it's creating more interesting effects. So super simple. I'm gonna go over here and I'm gonna choose which images I want to download. And in this particular case, we're only gonna be focusing on displacement. However, I do want to show you how to do diffuse, ambient occlusion, roughness, metallic, and the normal. So this 4 elements right here. Now, take a look here. It's very important whenever you're working with displacements. It's strongly recommended that you work with EXRs, 32 bits EXRs. Why? Because these ones are they're gonna have more information that the displacement will be able to read in a nicer way. So I'm just gonna download this. Let's wait for this to download. Whoa, what a difference! Whenever I'm in my like on the other CD with my family, the internet over there, it's not really good. So I struggle quite a bit. But yeah, let's go. So let's go here. There we go. Nexttut live assets, and yeah, displacement. Oh, I had this ones. Let's use this ones. So as you can see, we have the color, the ground, the displacement, and the normal map. Those are tileable textures. I think they're tileable textures, so we are going to be able to tile them if we need to. But now let's just jump into Blender. And I'm gonna go into this shading tab, which is where we create the shades, very similar to the hyper shade inside of Maya. I'm gonna create a new material. Let's rename this rock. Oh, rock. There we go. And you can just drag and drop all of the images into this area right here. So that's the diffuse. You can also do this in Maya, by the way. I think I've done this before. You can just literally drag and drop the images, and it just creates a texture node or texture element here. And now let's just connect. So this is the diffuse. The diffuse goes into the base color. You're gonna see this changes. Look at that, very cool. And then this one is the okay. This one is interesting because this one has a couple of information into the whole thing. It has ambient occlusion, it has roughness, and it has metallic. Right now, there's no metallic. Everything is a non-metallic object. But we do have ambient occlusion and other options. So to do the roughness, well, we need to split these channels. So I'm gonna press Shift A, and I'm gonna look for color. No, not color. Sorry, it's RGB. It's separate RGB. So we click this here, and now this node allows us to access each individual like entity of the whole thing. Because I don't think we have a split over here. In Unreal, we usually have a split on the node itself, and we can split this, but here we need this one. So the R is the ambient occlusion, and what I can do with the ambient occlusion is I can multiply it against the color so that we have a little bit more crunch to it. So I'm gonna use a node called mix. Oh. Shift A, search, and it's mix RGB. So I'm gonna be mixing the color and the ambient occlusion, and I'm gonna be multiplying. And if we go here, you're gonna see that the color becomes a little bit darker. We can modify the factor here and see how much like darkness goes into the image, and it will only go into the crevices. So once we do the displacement, this was gonna look a little bit better because it's gonna look a little bit darker, more contrasty. So very important. And again, all of this can be done in Maya. If you want me to do this in Maya, I can do it tomorrow. Just let me know, and I can replicate this whole thing, this whole process in Maya. It's pretty much the same thing. Now for the normal map, we also need another node here, which is called a normal map node. The color goes into the normal map, and then the normal map goes into the normal, like so. The only thing here is very important. Since this is a normal map image, we need to change the color space to raw, because it should only have like information. Now, if I were to go here, which is the main render, you can see that the normal is working. Like the light is making it look like this thing is raised. However, it's not. We know that's completely flat, right? And here's where the displacement comes into place. So the displacement is going to be done not on the main shader, and this is one of the things that when I was a student confused me quite a bit, because displacement has always been this sort of thing that's like mystic or something, and people don't really know how to get there. However, it's not that difficult once you understand how things work. So every single material is attached to this thing, which is called a shader network or a shading group. In Blender, they call it the material output, which is what's going to be outputted as a material, and you're going to be rendering on your camera. Pretty straightforward, right? And inside of Blender and inside of Maya, the material output has 3 channels. Surface, which is a traditional material, what we're seeing right here. Volume, if you want to render things like fog or fire or smokes, things like that. And finally, displacement. So displacement has to do with geometry. And we already have our map, which is this one right here. The only thing that we don't have is this thing is not like attached to this element over here. So I'm going to press Shift A, and I'm going to create a new node called a displacement node. And what I want to do is I want to inject the color into the height, and then the displacement into the displacement. Okay? Now, if I do that, absolutely nothing happens. And why is nothing happening? Because there's a couple of things we need to check before we can see the displacement actually working. First, for displacement to work, we do need a little bit more topology. So if we go into layout, let's turn this thing on again, which by the way, this is real-time rendering. We can go here, and I'm just gonna change this from Eevee to cycles. There we go. And as you can see, it's really fast. There's even like an on-screen denoiser, so you will get denoising. After a couple of seconds, it will just like kick in and denoise the whole thing. So it's amazing. I'm really surprised by what they've been able to do. And that's why I really like the fact that Blender is doing so well. Like 5 years ago, Blender was just like this underdog software that a lot of people use, but it wasn't really competing in the big leagues. And now it's really strong. And I like it because that sort of competition kind of incites more competition and innovation. So Maya has been super comfortable doing almost nothing throughout the last couple of years, and now they're gonna have to really pick it up because otherwise Blender is just gonna take over. So yeah, so I'm gonna go here and change this to GPU so that the GPU does the computation. And down here on the material, I'm gonna go all the way down here to displacement, and I'm gonna change the displacement right here to, where is it? We need to change this so that it's using, there we go. So on the settings, we're not gonna be using bump, we're gonna be using displacement only. And now, as you can see, my plane suddenly bloop, jumped all the way up. Why is this happening? Well, it jumped all the way up because there's only 4 vertices on my plane. If I check the edit mode, there's only 4 points. So it's just like trying to move those 4 points, and it's not possible. If I were to go into the modifiers now and add a subdivision surface, for instance, you can see that now with more points, the subdivision starts looking a little bit better. Let's add more. Let's say 1, 2, 3, 4, like that. And I'm gonna apply them because I realized yesterday that there's a limit at 6. So I'm gonna see, hey, 6, and then I'm gonna hit apply. Now these are my new points. As you can see, we have a lot of points, and you can see when I press tab here, which is going into edit mode, this is what the shape looks like on the world. Like if I were to turn the render off, this is what I have. But once we render, all of the points get pushed up and down depending on the image that we have, and they create this displacement, which looks very, very cool. Now, there's of course a couple of things that we can do. First, I'm gonna add another subdivision surface to give it a couple more subdivisions here on the render on my viewport. And on the render, I'm gonna go like kind of crazy, like let's say 5 subdivisions. So right now I'm not seeing 5 subdivisions here, but we will see them on the render. If we go back to the shading tab, there's a couple of things that we can modify to make this thing look a little bit better. First, there's the scale, either here on the displacement node, or if we select the material, down here on the displacement, we also have the scale. There are 2 different things, I believe. So if we move this thing to like 0.1, as you can see here, it's not affecting. Oh no, it's the same thing. Okay, sorry, my bad. It's the same thing. So yeah, so if I say, for instance, 0.25, you're gonna be able to see that we can create a very nice displacement. Look at this, very cool, right? Now, here's where you would need, of course, to check and see how much or how little displacement you want to have. But as you can see, this looks amazing. And this is real geometry. Like, the geometry that we're seeing right now is actually there. The vertices and everything are actually there, okay? So let me go back to layout. Let's go to the camera. Let's find like a nicer effect, something like this, so that we can see a little bit of the displacement. There we go. And now if I hit render, let's just hit render image. Now we're going to be rendering, and we're going to have 6 more subdivisions. So it should look even better than what we have on the viewport itself. There's a new thing that they added here in Blender. I was doing a little bit of research, where you can say how long you want the render to go for in times. So right now you can see that this is going all the way to 4,096 samples, and the max time, it's like 24 hours or something like that. That's way too much. So let me cancel the render here. And if we go to the options here, I can say, hey, you know what? I'm just gonna do a time limit of 20 seconds, and it will render only until it hits 20 seconds. So this option right here, if Maya had this, my God, that would be great. And why is that great? Small like tangent here. Whenever you're working on a project for like a client, and you're doing your calculations, like let's say the client wants the render done for this Friday, and the animation is like, I don't know, it's a minute of animation. So that's 24 frames times 60 seconds. That's 1,440 frames. And if I say, okay, each of these is going to take like 5 minutes, and I divide that between hours, so on that computer is going to take 120 hours. I won't make it. Like, I don't have 120 hours on my computer right now to do it. And unless I want to pay for a render farm, this is not going to work. So if I were to say, okay, I know that it's, again, 7, like this. And let's say, I'm going to say, okay, what would be my magical time? Well, I can do it inversely, right? I can say, hey, I want to spend only like 60 hours. So I'm going to say 60. And then divided by 60. So that means that it should take only 2 minutes, right? So if I do, again, this times 2 minutes. I told you I was super bad at math. Hopefully you get the idea. The point is you can calculate and say, okay, it's only going to take 2 minutes per frame. That's like this. And against 2 minutes, that's only going to be that amount of minutes. And we divide it in hours, and that's going to be 48 hours. So I know that in 2 days I could get the render done. So very, very quick way to do it over here. Let me show you the render here. Oh, let's render image. So now when we render, again, this thing is going to be constrained to those 20 seconds they added. Of course, like with every single render, the more memory you have, the stronger your computer is, the faster the whole result is going to be. So let's just give it a couple of seconds here. There we go. And look at that. Pretty cool, right? So again, this is the strength of displacement, guys. Displacement will actually move your geometry up and down. Now, because this is another very important question, should we use displacements all the time? Should we use displacements all the time? And my answer is, it depends. For instance, let's say you're doing a daemon on ZBrush, right? If your daemon is like this, and you have a fairly good like topology and normal maps and stuff, then you really don't need displacement unless you want to go like super like create like a super heavy zoom on the character, right? Because most of the surface is quite smooth. Like you can see the silhouette is easy to match with the traditional like just subdivision method. However, if you're doing things like this where the characters are like super crazy and the silhouette is super crazy and you're not able to catch all of the silhouette on your low poly, then displacement really comes into place. I've seen some crazy stuff with displacement, like this sort of stuff where you have like almost a sphere and then it gets displaced into this kind of thing. It's crazy. Like it is a very, very good process. It is a very, very good tool, but you need to be mindful that it is quite expensive. So it will take a little bit more time here. Okay, so yeah, that's it, guys. This is it for today. As you can see, displacements are really easy to set up inside of Blender. Again, if you want me to show you how to set them up inside of Maya, let me know and I'll be happy to do so. It's a very similar process. We should be getting a very similar result. And yeah, make sure to like, share, subscribe. Let us know if this series, like just basic tips and tricks, is good, and we'll be happy to continue it as well. And make sure to check Alejandro's video if you want to get a little bit more information about Blender. Get Blender 3.0. It's a really good tool. I've got no bad things to say right now. So the more tools you can learn and exploit, the better for your 3D career. That's it, my friends. I'll see you back tomorrow. Bye bye.